Okay, welcome to the 7.3 instructional video. This is where I'm just going to talk about some of the concepts that we're going to use in order to solve the material in 7.3. 7.3 is about solving absolute value equations, and it's actually pretty similar to what we did in 5 and 6. If you remember, and I know it's been a while, that chapter 5 was solving radicals, and we manipulated it so it was non-radical. Chapter 6 was solving rationals, and we manipulated it so it wasn't irrational. And then usually that gave us a linear or a quadratic, and we use the appropriate techniques to solve those. That's the same thing we do for absolute value equations. I am going to make a relatively simple equation, just the absolute value of x minus 3 is equal to 4, and we'll talk about this graphically as well. The way that we solve absolute value equations is basically splitting them into two cases. The first case is when the absolute value is of a positive number. The second case is when it's the absolute value of a negative number. And if you remember from 7.2, this is basically looking at it as a piecewise function. If x minus 3 is positive, then the absolute value does nothing. And we're left with x minus 3 is equal to 4. I want to add 3 to both sides. I get that x is equal to 7, and that's an answer. Now, this is definitely a simpler absolute value equation because it is linear, but the technique is going to be very, very consistent across the board. If we have the absolute value of a negative number, that means that the inside expression in the absolute value will be multiplied by a negative 1. Now, we do have to distribute that negative into the bracket. That gives me negative x plus 3 is equal to 4. What I'm going to do then is I'm going to subtract the 3 from both sides. I get negative x is equal to 1, divide by negative 1. I get that x is equal to negative 1. So those are two answers of solving that absolute value equation. Now, what's very important is you can check this a variety of different ways. One of the easiest ways by far is to graph the two functions. So if I made the left-hand side y1 the absolute value of x minus 3, what that looks like is roughly like that. So it's changing direction right here at 3, 0, which is where the pieces would split. If I then take the right-hand side, which is a simpler equation for sure, y2 is equal to 4, what that gives me is a nice straight line somewhere up here. And basically my two solutions are where they intersect, which is going to occur right here at negative 1, 4, and all the way over here, kind of tough to see, I know, but that point would be 7, 4. Now, verifying this graphically is a good idea, but bare minimum, you need to be comfortable verifying it algebraically. And to verify, we substitute into the original expression. So in order to verify this answer, what I'm going to do is check if the absolute value of 7 minus 3 is indeed 4. Well, 7 minus 3 is 4, and this leads me to the absolute value of 4 is 4, which is 4 is equal to 4. So that worked. When x is equal to 7, it satisfies the equation. We'll do the same thing on the right-hand side. If I verify that, I'm going to say that the absolute value of negative 1 minus 3 is equal to 4. This is the absolute value of negative 4. Much like I did in 7.2, I think it is a good idea just to a couple times write that the way that absolute value changes a negative value into a positive value is by multiplying it by negative 1. Well, negative 1 times negative 4 gives me positive 4. And again, we see that that equation is verified. Really, really important that you verify your answers. It happens a ton in absolute value equations that one or more of our answers actually ends up being what we call extraneous. So really, really important that the technique we're going to use is split our question into two cases. The absolute value of a positive case, the absolute value of a negative case, and then solve within those cases. And finally, verify our answers. Make sure you're watching more. I am going to go through a kind of a video per example as per the usual.